Okay, let's see question number 5 from October 2023 P3 paper. So basically question number 5 is from differentiation calculus part of P3. So in number 5, the curve C has equation. The equation of curve C is given where k is a positive constant. Okay, the domain of the equation of curve C is also given. So in part A, we need to show that the derivative of y, it can be written like this. Okay, that means we need to differentiate the equation of curve C. So to differentiate, if you see the equation of curve C, you can understand that it is in fraction form. That means one algebraic term is divided by the other in the denominator. So that means for differentiating the curve C, we need to use what? We need to use the quotient rule. For quotient rule, what we do? We take the numerator as u and the denominator as v. So what was in the numerator? It was ln x squared plus k, and in place of v, we will put the denominator, which is x squared plus k. Okay. So now differentiate. Now we will differentiate them simultaneously. Du over dx. So that would be du over dx. Du over dx. You will get 2x over what? X squared plus k, and dv over dx would be twice of x. That's it. So we differentiated u by using the chain rule. Ln something is 1 over something, so 1 over something is there, because in place of something it is what? X square plus k. So we put 1 over x square plus k, and then differentiated the part within the bracket, which is twice of x, and multiplied with the coefficient. So we got twice of x over x squared plus k. So the derivative of curve y dy over dx equals to what? V into du over dx. V into du over dx, it's what? Twice of x minus u times dv over dx, 2x ln x squared plus k over v squared. V is what? X squared plus k whole squared. Okay. Now we need to do what? We need to just take twice of x as common from there, from the numerator. We got the denominator as like as what they wanted. So we are done with the denominator. Just we need to simplify the numerator. So that's why we will take twice of x common. So twice of x goes to 1 minus ln x squared plus k. So we will get x squared plus k whole squared. That's what they wanted. So we got in the form they wanted. A is 2, the value of a is 2 there, and then the value of b is just 1. B is 1 there. That's it. That's the answer. Now for part B, given that C has exactly 3 turning points. How many turning points? 3. That means at 3 points we can have the derivative of y 0, right? So that's why we will put at first, for finding the 3 turning points, we can put what? We can put dy over dx. Dy over dx equals to 0 at those turning points. So we put dy over dx equals to 0. So what we can do now? Just write dy over dx is 0. So, that means x square plus k will cancel out, being multiplied with the 0 on the other side. So, we will get twice of x times 1 minus ln x squared plus k equals to 0. That means you will get either x equals to 0 or 1 minus ln x squared plus k equals to 0. Now, from there we need to make x the subject. So, take ln x squared plus k, on the other side you will get 1. So, x squared plus k equals to what? E to the power 1. So, what we can write, x squared equals to e minus k. So, x would be plus minus square root of what? E minus k. So, these are the three values for the what? For the turning points of the three turning points of the curve y. X equals to 0, x equals to 0, or x equals to positive e minus k, and the other one is x equals to negative square root of e minus k. That is it. Okay. Now, for part C, find the upper limit. Upper limit, what does it mean? Upper limit to the value of k. What could be the maximum value of k? We need to find out that. Okay. So, the curve y, the curve C, they said it has 3 turning points. So, in order to have 3 turning points, you can see that the derivative is 0. Okay, that is fine. Using that concept, like equating derivative equals to 0, we got 3 values, x equals to 0, x equals to plus minus square root of e minus k. Now, if you see the x coordinates of the 2 points, that is plus minus square root of e minus k, before the k there is negative, and it is this x coordinate e minus k, it is within a square root, and we know that within a square root there can't be any negative value, negative something, it is square root of negative something, this is undefined. So, that means k, the value of k can never be what? Greater than e, because if it is greater than e, then within the square root you will have a negative value, which will make the x coordinate of the turning point undefined. So, the maximum, the upper limit for value of k, it is what? E, just k equals to e. That is the answer for part C, and that is the end for question number 5.